Hi, this video is about the hidden AI secrets revealed by Snowflake CEO. In this video, he talks about something from a very high level that is just not common knowledge, that most people don't know about, that is critical to understanding how to build real-world solutions, and the reason why enterprise AI has not been adopted at the levels that people have expected at this point. And if you don't know what Snowflake is, they're one of the most popular, they might be the most popular cloud data service in the world. And even in this video, these smart people at Sequoia Capital that are interviewing them, which is they do a lot of really great videos on this channel. It should be more popular. It doesn't sink in. There's definitely some indications that it doesn't sink in very early on, and because he says the same point over and over again, and that's what I'm going to cover extensively in this video. And then there's another part of this that's kind of similar, it's related, where he talks about something dumb that you should not be doing with AI, and he talks about that later in the video, so make sure you watch all the way to the end. Okay, so let's get started on his quick intro here.
The product that makes even the people that go, I have GPT-4, I have an army of software engineers, the thing that even they struggle with is things like a reliable talk-to-your-data application. Because even with GPT-4 out of the box, you end up getting 45% reliability, meaning it gets half the questions wrong when it tries to answer it.
Okay, so this is a key understanding. It's not just about data applications, this is about AI applications in general, that right out of the box, when you're doing it wrong, or you're doing it in the way that, and he's going to tell you the right way, he's going to allude to it many times, and we'll go to it in a second, your reliability goes way, way, way down. It's very challenging for people, and it's because they're approaching the problem incorrectly.
We are well in the 90s, and we are racing to get to like 99% reliability on talk-to-your-data application.
So they are able to get very high into the 90s reliability. This is absolutely critical, and this is, to me, the main reason why a lot of enterprise AI is not effective, it's not being adopted, because you need reliability, and there's so many mission critical processes within an enterprise that 50-50 chance of something working is unacceptable. You need it to be extremely high, and he's going to give the secret here on how to do that.
Document AI, we just make a whole bunch of AI applications that previously used to be software engineering projects into 2 commands that an analyst can issue. And so, okay,
so this is a key thing that is misunderstood in the industry that leads people off onto the wrong path. And it's not that he's definitely right here, and that there is a certain amount of things that used to be software engineering that is now you can kind of let the AI do. But what is happening in the industry as a whole is they're taking that and extrapolating it way too far. He'll cover this a bit more in terms of, hey, let's just let the AI take over everything, and this is going to be the common theme that you'll see. Okay, so now you're going to see this Sequoia guy. In the way that he talks about it, he's going to talk about the wrong way, and it's implied in how he talks about the solution, and this is how just about everyone's talking about it. And then I'll start to show you some of the secret, the real answers that this guy's going to give over the Snowflake CEO over and over again in response.
Because one of the things that we have heard from customers is at either end of the spectrum, you've got at one end of the spectrum, work directly with OpenAI, send your data, into their cloud, and maybe have some nervousness around whether that data is going to leak into the model or whether they have the right security and privacy sort of governance around it. At the other end of the spectrum, you can just do everything yourself, grab a model off the Hugging Face, build it internally, super safe, super secure, but pretty painful to do all that. And then the middle ground, you've got Amazon Bedrock, or you've got a Snowflake, and they both kind of have a value prop.
Okay, now I'm going to skip ahead to the part where he addresses why, and I'll circle back around to why what he said was so wrong and so far from the correct answer. Okay, here we go. This is it. This is the first time he's going to say this, and he says this multiple times, and I'll show you the pattern as we go through multiple of his answers here.
And so 100%, you can work with CSPs, and you can be like, I have a model garden here, I have a caching service there, I have a database here, I will stitch all of this together. As I said, everything turns into a software engineering project. For us, you're like, no.
Okay, everything turns into a software engineering project. That is the key. That is a little sliver of understanding of the truth behind how to build these things. And what does that mean? That means that when we go back to what the Sequoia guy said in the previous clip, he talked about, he was like, hey, there's 3 different options. And it was model this, model that, model that. And that is an improper way to look at it because everyone is trying to solve the problems with the model. And then there's some other key things that he's going to go into here on what this means by a software engineering project. Okay, this is the excerpt that they pulled and put at the beginning because I think they realized this was critical. So I'm going to let him kind of finish this out as he talks more about everything becoming a software engineering problem.
Reliability, meaning it gets half the questions wrong when it tries to answer it. We are well in the 90s and we are racing to get to like 99% reliability on talk to your data applications. Obviously, we restrict the domain and turn this into more of a software engineering problem than just like a pure AI model problem.
There we go. He says it again there. That's a different time. He said it's a software engineering problem than a pure AI model problem. And that is the key that most people are missing. Again, he's going to go deeper into this. I'm going to show you a little bit more and give my comments on that. But almost everyone is trying to solve problems as pure AI model problems. And as a result, he talks about this here. There's a wall that they are not likely to break through. Even with a big software engineering team, they struggle with this because they're looking at it through the lens of a pure AI model problem.
Or AI model problem. But that's the thing that makes every Snowflake customer perk up and go like, I want that. Because even the people with the money and the resources to spend on software engineering teams very quickly realize that this is a wall that they are likely not going to break through.
Okay, so this is going to reveal that this is not sunk into this, a very intelligent woman here, clearly, but I don't think she really understood the point. And you're going to be able to tell by the way she asks this question that she's about to ask.
Accomplish that? Like maybe peel back for us how you were able to get to the 90%. Are you training your own models? Are you just tell us about how?
Again, her question is all about the models. She assumes that it didn't really sink in that it is not a pure AI model problem, that it is a software engineering problem. So much of the industry is so focused on LLMs, the LLM-centric solutions. This is going to take a while, and he's actually going to give a really good answer here that approaches it from a different angle in terms of what it is that they're doing.
How this all becomes possible?
It's systems design.
Okay.
Just like the magic of how you make
systems design. It's not just about the model. It's about how you put the pieces together, how you plug things together, how this part affects this part. He's going to go a bit deeper too.
A coding agent or less a coding agent, more an effective co-pilot work in practice. It's not always the giant models. It is carefully breaking problems down so that you present the right context to the model. It's in this
carefully breaking the problem down into smaller pieces so that you can really, here's another way of putting what he's saying, so that when you feed something to the model, you're not trying to feed it a bunch of stuff. You're feeding it one key thing that you're trying to solve. And it's not necessarily about the model. It could be about the prompt, focusing on solving one thing. And then my part on this would be, if you, what you want to do is you actually want to, if you can solve a problem with that part of the solution without an AI model, you should, because it's going to be faster, more reliable, and less expensive. And it also makes in that key thing being their reliability. So I'd actually take this even further than what he is going to say, what he said here. And he goes on to say something to the effect of, different models for different subtasks. Here, let's just let him go on.
Citing things like, oh, I see. The problem of answering a question, whether to answer a question, is different from how to answer the question. So you can specialize and have different models for these different subtasks. And also,
I would take this further and say it's not necessarily different models, but different prompts as well. Sometimes it is different models. So within one of the products that we built, we use GPT 3.5, we use GPT 4, and we use Claude at different places. But we also used, it wasn't just we used one model for every different time we called LLM. We sometimes we used in some places we use Claude multiple times, and in other places we use GPT-4. So multiple different prompts to the same model. With it's really the key understanding here are the subtasks. Okay, here's where he talks about trade-offs, and then he says the same thing over and over again here in just a second.
Making in order to create something that has broad applicability, and that's the thing that we have done here. We constrain the problem, but as I said, we also explicitly train for things like when to refuse questions, as opposed to trying to pretend that you can answer every question. But obviously there's a precision recall trade-off there. You can get 100% precision by answering no question. That's not the goal. We want to be useful but still be precise, but it's a lot of software engineering.
Again, this key software engineering. There's a lot of software engineering in the solution, and keep in mind that it's not like Snowflake solves all that, it has like all the AI applications nailed down. There's still kind of a niche in there, but there's some broader concepts that are true across what we've seen, a much broader set of AI applications, which is it becomes more of a software engineering problem. This is so key. And I'm going over and over again because I don't think it's really sunk into the industry. And if you really want to build real-world practical AI solutions, then that is the perspective that you should have instead of thinking about it LLM focused. Yes, sometimes it's useful to train or fine-tune a model for a very specific task, and that's totally fine and acceptable. But if that is all you're doing, if all you're doing is looking at it from a narrow model focus, then you're going to be extremely limited in your ability to provide real-world solutions that are reliable. Okay, so this is a really good question this guy asks that I don't think is really getting asked very much right now, because there's just an assumption that the progress of the models is just going to keep rocketing. The kind of thing that everyone is saying is, oh, AI technology just keeps moving forward. It's only going to get faster from here. And while technology in general, that's broadly true over a long period of time, there definitely will be fits and starts. And based upon a lot of data that I have seen, the models themselves from the LLMs have their progress has significantly slowed down. So let's see what this guy says, and we'll check out the answers, and it again reinforces the points I've been making throughout the video.
Delayed or not a big step up or whatever the case might be. Or if you just imagine a world in which the current capabilities of the foundation models, that's what we've got. And it comes down to how do we implement those, how do we optimize those, how do we tune those. One of the things that we hear from a lot of people building an AI, the first couple of weeks are like magic. Everything is amazing. Yep. This is great. Yep. And the next few months are pretty painful. Oh, shoot. It can't do this corner case. It can't do that corner case. It's not quite accurate enough.
Again, the reason why this is happening is because they're viewing it as a pure AI model problem. And so they're unable to get it to do what they want it to do reliably.
And people get really frustrated. And sometimes they can engineer their way out of it, sometimes they can't, but sometimes it leaves people feeling kind of disillusioned. Like, this stuff's not as good as I thought it was, maybe the time's not right. And so I'd love to get your take. If we froze the capabilities of the foundation models today, what sort of changes will we see in the enterprise landscape over the next handful of years? What sort of stuff will we not see because we're just not ready for it yet?
To me, this is honestly the magic of software engineering. Part of what I feel we have implicitly accepted with ChatGPT is it's sort of like its omniscience. We're like, it can do everything.
Okay, he says the magic of software engineering. Again, software engineering. This is a very reasonable question because I think that there is a reasonable chance that we look, as much as OpenAI and all the other big model companies want to, this guy has a funny look on his face, want to suggest that it's going to be able to do everything, or that it's going to just get exponentially better every single month, every single year. I don't think that is reasonable without some movement away from Transformer as the core technology, or a significant better understanding of, in just like industry focus on the software engineering over the actual models themselves.
As a set of regression tests, there is such a thing as acceptance criteria for software. everything that we have, like if somebody were to build a new application, like one of your founders, your expectation is that, you know, they got their clue together and are actually testing stuff before they give it to customers.
Yeah.
And somehow in the world of AI, we're like, no, it doesn't matter. And these models, you know, react pretty violently to the addition of a period in a prompt.
Mm-hmm.
And so I think there needs to be this idea that like you need good old-fashioned software engineering, and you need to
Good old-fashioned software engineering.
measure the performance of these things. And so I think this is where it goes, you know, away from these are hobby projects that can be hit or miss to, you know, here's somebody that can actually software engineer this for you. And
Software engineering. So that is the key that is getting missed. That is the key that all the people that I talk to that are actually building real world solutions, all these nerds that are actually out there solving real world problems, get this. And now there's a deeper level of understanding here. And I think when people hear software engineering, it's kind of a vague term. And he covered it from some different angles. And I tried to go a little bit deeper into it. So that is the secret. Now there's actually two more quick things that I think are pretty cool in here. One that I promised at the beginning, and then another bonus one, if you will, that I'll show here in a second.
you know, AI enthusiasm, it can do everything, but some of it is just also plain dumb. You should not be doing that.
He's referring to something that I keep talking about on this channel, which is there's a lot of AI enthusiasm, and they're trying, and people are trying to use AI to do things that they should not be doing, which is just, as he pointed out, just plain dumb. And so there's a lot of angles that I talked about earlier in this video and in some of the other videos that I've shot in terms of what is the dumb things to do. And part of it is it's not viewing it from a software engineering standpoint, it's viewing it from a very LLM-centric standpoint, or as he called it, a pure AI model problem. Okay, now here's the final piece of the puzzle, and this is something that is a pretty different point that I thought would be cool to make, that I'm gonna expand on what he says here, but this is really, really interesting, and I think very insightful of him to say, because I don't hear anybody else mentioning this.
We say that foundation model companies without a strong business to accompany them, it can be a product. Like I think OpenAI has created a pretty solid product. It's not just a foundation model.
Yeah.
I think that's one thing to keep in mind.
So he's kind of alluding to some of the things that he said earlier and that he talks about a little bit later, which I won't go take that too long. But basically what my interpretation of what he's saying, and this is what I've been saying, is I think a lot of these big foundation model companies are extremely risky. If I were an investor in them, I'd be very concerned. I mean, OpenAI might still not make it, and they're already getting a valuation of, I think they got a recent fundraising of 150 something billion dollars. And he says, well, you kind of have to have some sort of product to go along with that. And I would disagree with him. I think ChatGPT, if you take the model out of it, it's not really that good of a product overall. It's not like terrible, but it's not like this amazing product in and of itself. I think that there is, it's really, they're just leaning heavily on their models. And they just released the Canvas and the O1, which is, both of those are a little bit of a step away from just being a model company. So it's unclear if they're going to actually be successful with that, because they've tried like plugins and custom GPTs as like kind of productizing their models and have not been successful at that at that point. And also in a sense, I heard somebody else say this, and it's absolutely true, that they're kind of at this point they're kind of a one-trick pony, which is they have taken the models and they've been able to make them much better, and mostly by scaling. Now they're doing a bit more than that. So let's just say at least there's a reason to suggest that they're the best model company. But what kind of the implication of what he's saying here, and something that I've said many times before, which is the model companies could be very much in trouble, largely because of like Zuckerberg and open source. In order to solve these problems with software engineering, sometimes, GPT-4 or even GPT 3.5 solves it just well enough. So why do you need the better model? And the more we go along, the better we get at software engineering, the lighter the model you can solve it with. And that's actually what you want to do. If there's a key part of your solution your software that needs to be solved with AI, you want not the best model, you want the worst model, the lightest, the fastest, the least expensive model that you can use to solve it reliably. And so what this means is, as open source gets better, the threshold of the amount of the use cases that it covers gets more and more and more. And therefore, the amount of use cases that are needed, that the top tier foundational models are needed for, gets less and less and less. It's not exactly less and less, because there's some amount of like, oh, it can do new things that we didn't even think about before. But in general, I think that is a counter that isn't faster than the amount that the open source kind of catches up on. And so in that sense, foundational model companies, I think, are in a lot of trouble. I would not invest in OpenAI if I had the opportunity, and that is the reason why. I'm not saying they definitely will fail, but to me it seems extremely, extremely risky, and especially as the models become commoditized, then what do they really have? And that's kind of back to his point. They need some sort of product that enable that they or business model that they can actually make money on, which again hasn't been proven, I think, either way for OpenAI or these other big foundational model companies. So if you're still with me, thank you very much. Please like this video for the algorithms, and please leave a comment below if you disagree with me, or if you have any experience with the software engineering aspect of it, or people trying to solve this from a pure AI model solution. I'd be happy to hear from you. Thank you very much. Have a great day. Bye.